In these example problems, we are still working with our same function from the previous problem, and we are still incorporating function notation to solve for different values of x, or in our next problem, we'll be multiplying a number to our function. So, just like before, we will be replacing all of our x's with what is inside of our function. So, currently, my function was just an x, but now it has transformed into an x plus 1. So that means all of these x's right here are also going to change into an x plus 1. So the first thing I'm going to do is replace all of my x's, or substitute in the value for x's, which is x plus 1. So I'm going to bring the 2 down because the 2 doesn't have an x in it, it's just 2. But I will be placing my x plus 1 right in there for an x. And I'm going to put it in a parenthesis because the exponent applies to the entire number, which is x plus 1. I'm going to bring down my minus sign, and just like when we subtracted with two functions, I'm going to be placing this in a parenthesis, and I'll explain why in just a moment, so wait on it. I know you're so ready to find out why, but you'll have to wait. And then I'm going to bring down the 5 because it has no x with it. It does not have an x. So the first thing we're going to tackle is this x plus 1 quantity squared. So in our order of operations, you first simplify things within the parenthesis, but I can't combine my x and my 1, so the next thing in your order of operations is to apply the exponent before you multiply. So first thing, you're not going to distribute into 2, that's where the demon cats will get you. You apply the exponent, then multiply by 2. So the first thing we're going to deal with is just this part right here. So I'm going to work separately on that problem. So this part we have to be very careful about. This does not mean x squared plus 1 squared. No, that is where the demon cats will get you. Okay, whenever we square something, it means to multiply it to itself. If I have 3 squared, the reason why it's 3 squared, or if I have 3 squared, the reason why it's 9 is because you do 3 times 3. So we're going to rewrite x plus 1 quantity squared as x plus 1 times x plus 1. Always write this. It is not correct if you say x plus 1, so this is the not correct form. Don't ever try this, or the demon cats will come for you. This does not equal, the little slash means not, does not equal x squared plus 1 squared. Don't even try that. Okay, so we're going to be dealing with this right now. So what I'm going to do is I'm going to distribute each piece within my parentheses. So I'm going to start with the x, and I'm going to multiply x to each number in the other parenthesis. So x times x, remember there's secretly a 1 hiding out. And remember, when you multiply two variables with exponents, you have to add the exponents. So let's just bring this on down. So x times x will give me an x squared. Now I'm going to multiply my x to a 1, which x times 1 is just x. Okay, now I'm going to do the same thing, but now I'm going to be dealing with my 1, which I'm going to be multiplying 1 to each piece in this parenthesis. So 1 times x will give me an x, and 1 times 1 will give me a positive 1. And before we go back to our original problem, I'm going to combine all my like terms. That will be my next step. Okay, so remember, you start with the term with the highest exponent when you combine your like terms. So I'm going to start with my x squared. There are no other terms that contain an x squared in it, so I'm just going to bring it on down. It's all sad and lonely and by itself, and it has no one to combine to. My next two terms I'm going to look at are my terms that only have an x, and remember there's secretly a 1 here, so x to the first. Okay, so these two have an x to the first in them, so x plus x. Now this is a little different. If you don't see a number in front of the x, there's secretly also a 1 right in front of your x. So 1 plus 1 will give me 2. And remember, whenever you combine like terms, you leave the variable alone. So I'm going to bring down my x. Okay, my final number is a 1, and it has nothing else to combine to, so I'm just going to bring it on down. Okay, so far, what we have tackled is this right here. We still got to deal with the rest of the problem, but I promise those parts will not take as long. So I'm going to rewrite my original function, and I'm going to replace this x plus 1 squared with all that. But I'm going to keep everything else the same in the problem. So 2, and then up here we solve for this x plus 1 squared, so I'm going to write all of this in my parenthesis. Okay, and now I'm just going to bring all this down just as it is right now. Alright, the next big piece that we're going to be doing is a lot of distributing. The next step is to distribute. Which, remember, whenever you have a number in front of a parenthesis, that's what you're going to be distributing. Okay, which, remember, in front of my minus sign, if you don't see a number sitting there secretly, there's a negative 1. So I'm going to start by distributing my 2 to all 3 of these terms. So 2 times x squared will give me 2x squared. 2 times 2x, the 2 times the 2 will give me a 4. And I just bring the x down because I have nothing to multiply it to. And then 2 times the 1 will give me a 2. So that part is all covered. Heck yes. Alright, so next we're going to be distribute this negative 1 to each of these terms. So negative 1 times x will give me a negative x. Negative 1 times 1 will give me a negative 1. And then this 5, I'm just going to bring it down because it has nothing to distribute. Alright guys, so our last step in this problem is to combine all of our like terms, which we love to do. We're pros at that by now. Okay, so I'm going to start with my highest exponent term, which is my 2x squared. I look across, I don't see any other x squared terms, so I'm just going to bring it on down. Okay, now I'm going to move on to my terms that have the next highest exponent, which is x to the first. Which, remember, there's not an exponent there, there's secretly a 1 hiding out. So the other term that contains an x is this term. Which, remember, if there's not a number in the front, there's secretly a 1 there. Same if there's not an exponent, there's secretly a 1 there. So I'm going to combine my 4 and my negative 1. 4 minus 1 gives me 3. And remember, you just leave the variable alone when you add, so just x. Alright, now I'm going to combine all the terms that do not contain a variable. So my 2, my negative 1, and my 5. So 2 minus 1, that gives me 1. And then my 1 plus the 5 will give me a 6. So again, 2 minus 1 is 1. And then 1 plus 5 is 6. So this would be my final answer. Wasn't that exciting, you guys? I had a blast. Now you probably want to hit pause on this video and go back to the Prezi, because I'm just going to explain what this notation briefly means, and then we'll dive right back into our final example problem of this section. Holy hot dog. Alright, so hopefully you watched the Prezi, so you know that now we're going to be multiplying the 3 to our function, which is slightly different than what we were doing over here. Okay, so this one's a little different. Before, we were replacing x's with values in our function because our x turned into something else. Well, now, if you look over here, x didn't turn into anything. It's just x. We have a number sitting in front of the function, though. So all this means right here is we're going to take the 3 and multiply it to our function, which is f of x. So we already know our function is this. So when we solve this, let's see here. I'm going to write the 3 in a different color just to differentiate it. So 3 times f of x. So I'm going to start with my 3. And then it's 3 times f of x. So I'm going to multiply my 3 to my f of x, which I'm going to be putting f of x in a parenthesis. Whenever you multiply a number that has more than one term, we always stick it in a parenthesis. Okay, so it says 3 times f of x. So I'm going to be substituting my f of x into that parenthesis. F of x, which is right here. So all that. So this time we're going to insert all this into our parenthesis. Okay, so 3 times f of x, which f of x is 2x squared, minus x plus 5. Alright, and then after this, we're just going to solve. So remember, we leave this stuff alone. A lot of students try to do something with the f of x, or try to do something with the f of x plus 1 when they get done, but don't. Just leave it alone. So we're going to leave this side alone. So all I'm going to do now is to distribute my lovely 3 to all of my terms. So 3 times 2x squared will give me a 6x squared. My 3 times a negative x will give me a negative 3x. And then finally, my 3 times 5 will give me 15. And bam, we're done. We have solved for 3 times f of x. Alright guys, get ready for the next section.